Okay, so good morning. I will start writing some questions here. Don't waste your time. We'll start working on them so that people can have time to arrive. Okay, so I have written down ABC formula here for you. So I wrote it in this way that I taught you, but you can combine them. You don't need to follow exactly what I have written here, but this is the formula for ABC formula. If your equation is of this form, the answers that you get are this. D is called the discriminant, and it is defined in that way. If you want to use PQ formula, then you have to respect that this number is 1. If it is not 1, you have to divide by that number first. The downside about, or the disadvantage of doing that is that you might face working with fractions, but you are good enough in fractions, no worries. The formula seems a little bit simpler than that. Of course, the price that you pay for this simplicity is to work with fractions most of the time. So in that case, this is the discriminant, okay? So I have written down the formulas, but I really recommend you sooner or later memorize one of them because it would be ubiquitous in mathematics and it will repeat itself all the time. So, yes. And I will start writing questions, you start working on them, we go back together and then discuss about the problems when everyone arrives, okay? Okay, now I remember there was one question, I wrote it on the board, but we didn't solve, so I put it here. Now we start solving the problems. Okay, so the first problem here, all of them are simple, I think. I mean, might be they are lengthy, but you don't need to be creative to solve them. So hard problems are the ones that you have to be creative for. So here, I will explain everything from scratch if you have been absent or not following. So of course, you know that I am uploading the videos on YouTube, so you can access them. So the first question is, let me don't write the question itself. The question is on the board. I see that this is a quadratic equation. If I insist to use PQ formula, then I have to divide by 25. So for example, this becomes 9 over 25, then I have to work with a fraction. But of course, the numbers are big. If you want to divide, you have to work with big fractions. So this is why I want to avoid using PQ formula, at least for this problem. And I want to use ABC formula. So in order to find ABC formula, I write everything down, but you don't have to do it in the exam. If you can do things faster, do them. Okay? Otherwise, just do what I do here. So the first thing I do is I realize what is A. What is A? 25. You don't need to write them. Okay? What is B? Be careful. Minus is included. C is 9. Then I calculate this. What was the name of this? Discriminant. So I calculate the discriminant, which I have this formula. So I try to repeat it so that I can memorize. So be patient. B is minus 30, then to the power of 2, minus 4 times A is 25, times C, which is 9. If you can do it in your head, do it, otherwise you use the calculator. But what happens here, this is easy. Minus 30 to power 2 is not hard to calculate, it's 900. But then minus 4 times 25 is minus 100. Minus 100 times 9 is minus 900. And the answer becomes 0. So this means that the discriminant is 0. So what do you anticipate for the number of solutions? 1. What was the name of that root? It was called double root, the double root, yes? So remember, so this already indicates discriminant in mathematics is something that when you calculate, predicts what will happen for that thing, yes? So here we know that my quadratic equation has one single solution. So if d is 0, the square root of 0 is 0, plus 0 or minus 0 doesn't make any difference. So that's just minus b. So the answer, x, becomes minus b over 2a. And then, of course, minus b is minus 30. 2a is 50. So it is 30 over 50, but don't leave it like this. What is the answer? 3 over 5. In this case, if you write 0, 6, that is acceptable because that is exact value. Yes, so that's the answer. So this quadratic equation has one double root. It means that both roots are the same. Okay? But there is an alternative to solve this. If for some accident, if you are observant enough, more experienced, might be you immediately realize a pattern here. Yes?
5x minus 3 squared.
True. That's the simplest way. So I would say here in this case, another method. This is not a have to. Might be you cannot see the pattern. This is the good thing. These are algorithms. Even if you cannot detect a pattern, this will solve your problem. But of course, if you get some patterns, if you have more experience and you can immediately catch the patterns, your solutions for that problem become simpler. So how did you have any clue that this might be a squaring rule? Because I have 3 terms involved and 2 of them are complete squares. So this gives you already a clue that might be this is the case, but not always. So what I want to factorize this part to 5x minus 3 to power 2. But this is not guaranteed yet, I have to double check. Do you agree with me that this is correct? Let us check. The first one squared is 25x squared. 2 times the first one is 10x times minus 3 is minus 30x. That's correct. And the second one is squared. So that was much simpler, but of course, you have to be careful and observant enough. And then how can I solve this problem? I say to myself, I don't know this number, but I know that this number to power 2 is 0. So what can I conclude about the number that I don't know? That number has to be 0. And then what is the answer? 5x is equal to what? Is 3, and then x becomes 3 over 5. And which is exactly the same answer I got there. So if you write this in the exam, that's completely okay, and even sometimes I would say that this is better. But the point is that usually if the numbers are big and I don't have enough experience, I cannot come up with this myself, okay? Okay, so now let us go to the next one. So I want to do the same thing. If any questions here? Yes?
Is minus b multiplied by the discriminant in the ABC formula?
No. Plus or minus. So in principle, if you are confused, I can modify this a little bit like this. So it is minus b plus or minus square root of 0. Yes, because d was 0. But the square root of 0 is 0. Plus 0 or minus 0 doesn't make any difference. So I don't write it down. Only for this case. Okay, so now go to the next one. I will repeat the same thing. For this problem, I have 5x squared. So a is what? 5. What is b? 6. And what is c? Minus 8. The first thing I do, I calculate the discriminant. So this is 6 to power 2 minus 4 times a times c. So I calculate that this 1 to power 2 is 36. Be careful not to confuse here, so not to get confused. Minus 4 times 5 is minus 20. Minus 20 times minus 8 is plus 160. And the answer becomes 196. Let us review. If this number becomes 0 like that, I have one double root. In principle, I have one number involved. If it is positive, how many numbers I will get? 2. And if it is negative, nothing at all. Yes? So remember these things. Okay. So now that I have my discriminant, I write my formula. It's minus b plus or minus a square root of my discriminant divided by 2a. So this becomes minus b. b is 6. So minus b becomes minus 6. But plus or minus square root of 196 divided by, let us do this in our head, 2 times a, which is 10. So if these level numbers are there in the exam, definitely I will allow you to use the calculator, but just the calculator on the exam.net. So that is not a very advanced calculator, but that's enough to calculate this. So, but I have this in my memory, a square root of 196 is 14. If the square root of, for example, let us say that I have 197, then a square root of 197 is not a complete number, so you have to keep it like this. You have to keep it as a square root of 197. Do not simplify. But here in this case we simplify because this is a good perfect square, so it becomes 14 and then divided by 10. Then from here I have two scenarios, yes? I once consider the positive sign, once I consider the negative sign. And then you have to simplify. So this becomes what? 8 over 10. Or I simplify it to 4 over 5. Here it becomes minus 20 divided by 10. I simplify it to minus 2. So if I want to write the answer, I have two answers here. One of them is x equals to 4 over 5. The other answer is x equals to minus 2. Some books, I think some, even your book, sometimes they put x number 1, x number 2. If you want to do that, it doesn't matter which you call x1, which you call x2. That's it. Any questions? But that's more or less the same thing. You are repeating it. For the third one, of course, you have to do some expansions first, because that is not ready-made yet. I have to put it in the ready-made form. Okay, so what should I do? What is the first step I will do here? I will multiply them because there are no rules here, but instead of multiplying here, I want to use my rule. That's it. So I will start doing that. So, where is this pointer? It's here. So here I multiply 5x by x, which becomes 5x squared. Then I multiply 5x by minus 5, which is x, and then minus 3 times x, and then minus 3 times minus 5 plus 50 equals to. Here you know the rule. The first one is squared. Yes? 2 times the first one times the second one, which is 2 times the first one is 4x, times 5 is 20x. And then finally, the second one is squared, which is, but it is not finished because I have 1 plus 90 at the end. Yes? And then I start simplifying things. It depends how you want to do it, but let us just do it side by side first. So this becomes 5x squared, this becomes minus 28x, this becomes 15. On the right hand side I have 4x squared plus 20x, and what is that number? 115. You see, you realize, be careful here, this is not, you understand that this is a real quadratic equation because x squared survives. In that case, the formula tells you that if you want to use me, the right hand side should be 0. So you move everything to the left, not only x's. In first degree equations, we move x's to left, numbers to right. But for ABC formula, everything should be moved to the left after you realize that, yes, this is a quadratic equation. So let me just do it in 2 steps, but you can always do this in your head. And it's better to be fast. I move this to the other side, make it negative, move this to the other side, make it negative, move this to the other side, make it negative. What is left on the right? Nothing, 0. And then this one and that one are similar. This one and that one are similar, which is what?
Minus
48x. And this one and that one?
minus 100.
Minus 100. Okay. So to have some experience about PQ formula, it is better to use PQ formula here because it is well adapted to PQ formula, yes? Because you see this number is already 1. So it is better to learn both of them, but one of them is enough. So here, What is my P in this problem? Let us use PQ formula. Is what? Minus 48. And what is my Q? Minus 100. I hope that I'm not confusing you. You can just learn one of them and follow. If you want to use one of them, I recommend you that should be ABC formula. But if you can adapt yourself with both of them, because both of them are in the formula sheet. Okay? So why did I choose to use PQ formula here? Because this number is 1. And if it is 1, this looks a little bit simpler. Okay, so now can you help me? The discriminant is not as before. The discriminant is P divided by 2 to the power of 2 minus Q. So let us do that. So this number divided by 2 to the power of 2 minus Q itself is minus. Yes? And then of course if you need calculator you can do that, but let us try to see if we can. So what is this number? Minus 48 divided by 2 minus 24. And then you square it. But minus 100 is what? Plus 1. What is that number? 24 to power 2. What? 550, 80, 76, yes? Plus 100. And then it becomes what? 676. Yes? So now you can still predict how many solutions you expect, because the discriminant is positive, 2 answers. But be careful here, I want to use PQ formula. So I want to use this. So x becomes what? X becomes minus P over 2. I have already done that, be careful. Minus P over 2. So P is this one, divided by 2 is minus 24. If you want, I can write it in front of your eyes. Minus P divided by 2 plus or minus a square root of D, 676. Is that a friendly number? Did you check it? 26. So it becomes minus are gone. This becomes 24 plus or minus 26. Then I have 2 scenarios. One with positive sign, one with negative sign. So this becomes 50. This becomes minus 2. Yes? So the answer is what? X is equal to 50, one answer. X equals to minus 2, the other answer. So this is the finalist. But don't think that this is a hard question. This is not E-level question, but this is not A-level question. This is a C-level question. So it is lengthy, but it is a straightforward. Okay, so let us also do this with GeoGebra to make sure that you understand how to do it. So if I go to GeoGebra, if I want to solve it, I prefer to go to CAS view. It is better because we can see that how it works here, but it is better to go to CAS view because in the algebra view, it gives you approximations. So let me go to choose my view. I want to get rid of this, that's good. And then I start with typing solve. When I type solve, you have a lot of options. Usually equations are in mathematics in X, so choose the first option. If your variable is different, choose the other one, so that you can give the name of the variable as well. So I will choose this one, and I type my equation. So what was my equation? I would open a pair of brackets, 5x. Can you read it for me, Omar, please? 5x minus?
3.
Yes?
X minus 5.
X minus 5
equals 2x
equals to 2x plus 5
squared
to the power of 2 plus 90. Yes, thank you. And then you solve it. And these are the answers. So I think it is better to learn. Don't forget about these, because every time you want to think what was the syntax or command, it's not good. So that GeoGebra is not the best one, but it is the best free one, I think. Yes. Okay, so that's it. So we have done it right. So the next one is also a good one. I want to see how we solve this problem. But technically speaking, this problem is the same. Which one you prefer to use, ABC formula or PQ in this case? What? ABC. Let us use ABC. Because for PQ, you have to adapt it. How? By dividing by square root of 2. Yes, so here I think, let us solve it in this way. You need to write what is your A. What is the A? Square root of 2, x squared. Sorry, x squared is not included. B is what? Minus 2 square root of 3. And C is again square root of 2. So the first thing that you do is to calculate discriminant. You have decided to use ABC formula. So the discriminant is this one. Okay, so B is this number. So I put minus 2 square root of 3 in a pair of brackets to the power of 2. Minus 4 times A times C. That's it. But can you tell me what this number is?
4.
4
No, times 3.
times 3. Why? Again, if you have forgotten, if I give you x times y to power n, you are allowed to write x to the n multiplied by y to the n. Here, 2 is playing the role of n, minus 2 is playing the role of x, and the square root of 3 is playing the role of y. So this becomes minus 2 to power 2 multiplied by square root of 3 to power 2. And then what is this number? Square root of 2 times the square root of 2 is how much? 2, because it becomes the square root of 4. Square root of 4 is 2, and then you multiply it here. This one is 4, this one is 3, so it becomes 12 minus 8, which is 4. How many answers you predict? Because this is positive, 2 answers. So what should I write? So I would write x is equal to minus b plus or minus the square root of the discriminant divided by 2a. B itself is negative. There is also a negative sign in the formula. So what happens? It becomes positive. Plus or minus square root of 4 divided by 2 times a. A is this, so it becomes 2 square root of 2. Yes. And then what is the square root of 4? 2. That is not wrong. You cannot simplify it that much, but as Omar said very nicely, that you can factor a 2 and cancel factors. This is a have to. If you don't do that, you will lose some points. So between these two, I factor a 2 out. What happens here? It becomes the square root of 3 plus or minus 1. Why is that? Because if I multiply it back, it gives me this. Why I did this? Because I want to simplify. I can only simplify common factors. So this is a common factor now. So 2 and 2 are gone. So I get what? Square root of 3 plus or minus 1 divided by square root of 2. Yeah, so these are the answers. So one answer is the square root of 3 plus 1 divided by square root of 2. The other answer is square root of 3 minus 1 divided by square root of 2. So this is the answer that you provide. I doubt that the GeoGebra will give you this answer exactly. Let us try to understand that answer as well. Any questions for the time being? So even the numbers are not that user-friendly. If you can be patient and do it step by step, it is not hard. Yes, understandable? Okay, but let us see how GeoGebra reacts. Let me go here. For the time being, I want you to see the difference. So let me go to algebra view as the default view and type my equation here. So what is that? It is solve. Yes, be careful. I want to show you the difference between these environments. So if I do that, I would write square root of 2. So I use the virtual keyboard here, square root of 2. And then I come out from the square root sign. If you want, you can put multiplication sign, and then I have x to the power of 2. And then what is the next one? Is minus 2 square root of, oh, sorry, I forgot to put the minus sign. So minus 2 square root of what? 3. And then I come here, if I want to, I can put dot here, then x. And then what is the other one? Plus square root of 2. So I think GeoGebra did it right here. Yes. So these are the answers. So I was thinking that GeoGebra will give you approximate values, but it gave you exact values. Okay, but these are not my answers, apparently. This is why usually in mathematics, mathematicians don't like to put this search sign in the denominator. It is not wrong. If you write it in that form in the exam, I give you the full points. But I also want you to understand why there is a difference between the way that I have written my solutions and the way that GeoGebra is providing the answer. This is called rationalizing the denominator. Okay, so let me just talk to you a little bit about that. You see here the search sign appears both in the numerator and the denominator. Rationalizing means write a number equal to this number without having the search sign in the denominator. And you don't need to worry, even you might make it more complicated. That is not the goal. The goal is to get rid of the search sign in the denominator. I want to teach you this one so that you understand the difference. This is a technique. I mean, you need to learn that. I told you that. In the exam, you stop there. That's okay. But now that I am teaching you, might be I ask you rationalize your answers. Then you need to know what I mean by rationalizing. If someone asks you what is the meaning of rationalizing, it means to write something equal to that number without having the search sign in the denominator. Okay? This one. Okay, when I want to rationalize this, the idea is to do this. I multiply it by the same number and then divide it by the same number. You might say why I'm doing it. So you understand that this equality holds. Why? Because I have done nothing. I multiplied by this and then divide by this. You might say why this is useful. I'm not saying it is useful or not useful. I am saying that I have a goal. My goal is to get rid of the search sign from the denominator. And this will help you. Why? Because now what happens, I have a fraction, I have another fraction. First of all, what you see here is the same number. I am not changing anything. On the other hand, if I multiply them case by case, square root of 3 times square root of 2 is square root of 6, plus 1 times the square root of 2 is the square root of 2. Divided by square root of 2 times the square root of 2 is what?
2.
The square root of 4, which is 2. You see, this number and the original number are equal, but then I do not have a search sign in the denominator. Of course, I paid the price. The price was to, instead of working with square root of 3, which is a smaller number, I have to work with square root of 6, which is a bigger number. But that is what it is. Yes, so that is the meaning of rationalizing. Rationalizing a fraction means write an equivalent fraction so that you do not have a search sign in the denominator. Is that clear? Okay. Now, this is why GeoGebra provides these answers. Is that clear now? The next one with the negative sign is coming from the rationalization of this one. Okay? I will talk about rationalization a little bit later because I saw some exercises in your book, but let us not deviate from what we are doing. Okay, now I want to teach you a little bit more conceptual problems that you will find them as A-level questions. Okay, so these are sometimes easy E-level questions, sometimes a little bit more lengthy C-level questions, but you don't need to be creative in solving them. So they do not deserve A-level questions to be labeled by A-level questions. So these type of questions I want you to understand. Okay, the very first one, let me write the examples because usually these are word problems. So example, determine m such that three is a root of the equation x squared plus mx plus 3 equals to 0. Then determine the other root. Okay, so I want to give you a little bit of time to read the problem again for yourself. Okay, so do you understand what the question is? So the question is not asking you to solve an equation. It is asking you to fine-tune this number, which is called the parameter in my problem, in a way that if I replace it with the number and solve it, one answer becomes 0. So you see what I mean? I can choose different numbers for m. Every choice of m gives rise to one quadratic equation. For example, I can choose m to be 1. Then what is my equation? It becomes x squared plus x plus 3. I can choose m to be 2. Then I have another equation, x squared plus 2x plus 3. And I can solve each one of these equations. But my goal is to choose that m so that when I choose that m and solve my equation, one answer becomes 3. It is not guaranteed, you know. I can choose different values for m, and I can produce different quadratic equations, but if I want to do it randomly, there is no guarantee that those equations that I get and solve have one answer to these 3. Okay, I don't want to do random things. I want to systematically solve the problem. Okay, so what is your take on this? These level questions are harder questions, and you will have them both in exam and quiz. So try to learn them, yes?
Is it A question?
Yes, I will make it an A question because the algebra is so simple, it doesn't deserve an A-level questions, but understand, I'm just developing your understanding about the concept. So how do we solve the problem? Yes?
We replace x with 3.
Yes, we replace x with 3 and find m. So the logic is a little bit different. Okay, why? Because you are telling me you want to fine-tune m so that 3 is a root. But what is the meaning of being a root? It means it satisfies the equation. Yes, so you will write something like this. 3 is a root, or you say 3 is supposed to be a root. From this sentence, what can I say? I can say that this 3 satisfies my equation. It means that if I replace x with that number, the equation the equation holds. So this becomes 3 squared plus m times 3 plus 3 is equal to 0. Yes? This is the meaning. If you tell me 3 is a root, it means it fits my equation. It means when I replace x with this given number, the equality that I get is a true equality. But then you see that I can solve and find m. How? This is 9. This is 3, it becomes 12. This is 3m equals to 0. Yes? And then I move 12 to the other side. It becomes minus 12. M becomes what? Minus 4. This is what I expect you to write as the answer to the first part of the problem. What does it mean? It means that among all infinitely many choices that I had for m, only m equals to minus 4 will give rise to a quadratic equation for which one answer is 3. And then Determine the other root. So what should I think for the next one? What do you think I will do?
Replace n.
Yes, I replace the m I found here, then it becomes x squared minus 4x plus 3 equals to 0. And I start solving it. I want to test your understanding. What is your prediction about one of the roots that is coming? Yes? No? No. I'm not saying one is wrong, but one is not the one that I can predict immediately. One of the roots I can predict immediately. What is that one? 3. Because I myself chose m in a way that one answer is 3. So if I haven't done any mistakes when I solve it, one answer is definitely 3. Let us check. If you don't mind, let us use PQ formula. Okay? T for PQ formula. Let us now try to do it in our head. The formula is up there for dpq formula. It is this number divided by 2, which is minus 2 to the power of 2, minus q, which is minus 3. So it becomes 4 minus 3 is 1. Yes? And then I solve the formula minus p over 2 plus or minus the square root of t. Minus p is 4 divided by 2 is 2. So the answer is 2 plus or minus the square root of 1. So this becomes 2 plus or minus 1. And what are the answers? One of them is 3. If I choose the positive sign, one of them is 1. 3 shouldn't be surprising for you, because you yourself chose m in a way that one answer becomes 3. Do you see me or not? So you are shocked. Are you shocked? No, you understand? Okay. So is that right? So the question is that I chose m to be minus 4. It gave me an equation so that when I solve it, one answer becomes 3. The question is that what is the other root? What is the answer? 1. Is that clear? So these type of questions are not hard algebraically, but they are conceptually harder. Now I want you to learn them because that's important. Any questions? So the answer to the first part is this one. If I get part 1, let me write part 1 and part 2. So the answer to part 1 is m equals to minus 4. The answer to part 2 is x equals to 1. Is that understandable? Okay, so we want to train ourselves a little bit about these kinds of problems, but now harder. Okay? So I will write another one on the board, and I want you to think, to talk to me about it, because this is not just technique. You have to develop the concept in your head. You should be able to read the math text, analyze it, understanding what is the demand in the problem, and then try to solve it. Okay, so let me write one. We will practice more on these type of problems, but they will definitely be in your exam. Okay, so determine m. So let me write example. First, I want to hear from you. How do you understand the problem? So determine m. I can say determine the parameter m, but I just say determine m such that the quadratic equation so this is the equation. Let me see, what is that? M plus 2 multiplied by x squared and then minus 2mx plus 1 equals to 0 has a double root. What is that double root? Something like this. Okay? So now I want to hear from you. Read the question once more. Okay, is that understandable? So let us see what does it mean. It means that if I ask you what is this equation, you will tell me this is a quadratic equation, but because I have two variables, it is quadratic in variable x, but it is first degree in variable m. Yes? But that is not the problem. Here, I have asked you to determine m such that this quadratic equation, so I am meaning that this is the quadratic equation in x. So you know that if I choose m, different numbers, I will get different quadratic equations. For example, let me change my color, this is just explanation. So might be you choose 0 for m. Then what do you get? You get 2x squared, 0, plus 1. This is a quadratic equation. Okay, I can choose m to be minus 1. This becomes 1, so it becomes x squared. This becomes 2x, sorry, and then plus 1. This is another quadratic equation. So if I say how many quadratic equations you have, you can tell me infinitely many, one for each choice of m. Okay? For example, here, there are no solutions. Here, there are one solutions. I want to fine-tune that m in a way that the equation generated after it has a double root. So I cannot just do trial and error unless I'm very lucky, yes? So I want to systematically guess that particular value for m so that when I replace m with that number and I get a quadratic equation, when I solve that quadratic equation, among three possibilities, I have the one which gives me the double root. Yes? Is the explanation clear? Yes?
This is 0.
You're solving it. But my explanation is clear or not? Is the goal of the exercise clear?
Yes.
Okay. So now I want to solve it systematically. So how can I solve it systematically? The first thing that I need to ask myself is that what is playing the role of A in this problem? Can you tell me?
M plus 2.
This is playing the role of M, exactly. M plus 2, and I don't need the pair of brackets here. So what is playing the role of B in this problem?
Minus 2m.
Minus 2m. And what is playing the role of C in this problem?
1.
1. What is my demand? My demand is to have a double root. Then you need to ask yourself, when the quadratic equation has a double root, you remember that the discriminant should be 0. So then you say that, okay, to have a double root, what should be 0? D should be 0. What is D? D has a formula, which is b squared minus 4ac. Yes? So, what is b? B is this guy. So it's minus 2m to the power of 2. Minus 4 times a. I need a pair of brackets here because minus 4 is supposed to be multiplied by the whole a and then multiplied by c. Before jumping to put d equal to 0, let me simplify this. So what happens? It becomes 4m squared. I multiply minus 4 in, 1 is no matter because multiplication by 1 doesn't matter. It becomes minus 4m minus 8. So if I ask you what is my discriminant, you will tell me this is your discriminant. Is that right or not?
Yes.
This is a level question. Okay, so now to have a double root, d should be 0. So it means that I have to put d equal to 0 myself. Okay, so what happens? It means that this d should be 0. Okay, and I want to find m. So can I find m again? Yes, but this is a quadratic equation. Now in which variable? In m. And this plays the role of a, this plays the role of b, this plays the role of c. So it's a quadratic equation within another quadratic equation. So that is a conceptually hard question. So if you can cope with it, it means that your understanding is perfect. Is that clear? But we haven't answered that yet. So start solving this. How? by giving the role of A and B and C to something else. But I don't have to do that immediately because I see something that can simplify my life, yes? I can see that this number and this number and this number are all divisible by 4. You can choose work with these numbers, but why should I? I divide everything by 4. So then it becomes m squared minus m minus 2 equals to 0 over 4 is 0. Instead of solving that one, I solve this one. Okay, so let me write this on top of the board here. Now my goal is to solve this. Okay, can you see that this is also a quadratic equation?
Yes.
Yes, but m is playing the role of x. So what is a in this problem now? 1. Or if what is b in this problem? Minus 1. What is c in this problem? Minus 2. You can use PQ formula as well because this is 1. But let us do the d. Don't get confused. This d is not the original d. The original d was for this equation. There is another d here. Okay, so what is that? B squared minus 4ac, but b squared is minus 1 to power 2 minus 4 times a times c. Minus 4 times a times c. Okay, so what happens? This becomes 1, this becomes positive 8, it becomes 9. And then what should I write here? I want to find m. So I want to use ABC formula, but don't write x. What should I write here? M. Yes? Because m is my unknown now. Okay, so I would write the formula m equals to minus b plus or minus the square root of d over 2a. My b is minus 1, so minus 1 is 1, plus or minus the square root of d divided by 2 times a. So then it becomes 1 plus or minus 3 over 2, because the square root of no is 3, and then I have two answers. 1 plus 3 over 2, and 1 minus 3 over 2. So this becomes 4 divided by 2 is 2. This becomes minus 2 divided by 2 minus 1. So the answers are what? M is 2, M is minus 1. Okay? So this is a level question. You will receive such a question in the exam and quizzes. Okay, I want to understand what is the meaning. If someone asks you, what did you find? What do you say?
M is equal to 2.
What is the meaning of m equal to 2? It means that if you go back here, put m equal to 2, what do you get? What do you get? You get 4x squared, yes, minus 4x plus 1 equals to 0. This, if I haven't done anything wrong, this means that when I put m equals to 2 here, I generate this quadratic equation. But if I solve this quadratic equation has a double root. Okay? Can you see that? Without ABC formula, this pattern should look familiar to your eyes. Yes, what is that? This is 2x minus 1 to the power of 2. Yes? The first one squared, 2 times the first one times the second one squared, equals to 0. What happens? 2x minus 1 becomes 0. And what is x? X is 1/2. How many answers I got? 1. So that's the double root. Yes, because quadratic equation, having one answer, it means that one answer is the double root. So that is the double root. So you see, it was not random. And m equals to minus 1. If I put minus 1 here, minus 1 plus 2 is 1, so it becomes x squared. I put minus 1 here, it becomes positive 2x. And then I have 1 equals to 0. Again, this should look familiar to your eyes. What is that? It is x plus 1 to power 2 equals to 0. And if I ask you what is the answer, so you will tell me x plus 1 is equal to 0. And then what happens? X equals to minus 1. Yes? So it means that there are two numbers for m which gives rise to an equation. Both of them has one double root. Yes, so that is an A-level question. So you have to learn about it. Any questions? I don't know if I can make this simulation here on GeoGebra. Let me try to understand what does it mean. For example, let us start asking GeoGebra to solve this equation. Of course, GeoGebra, I think it will start solving it, unfortunately. So let me see, I'm not sure. I'm just testing this idea. If I just type that equation in GeoGebra, m plus 2, and then I have x to the power of 2, and then what I have minus 2, and then it's important to put these dots here when I have different variables. So might be it's a good idea to put dots there as well. So, and then let us see if it works. And then plus 1. And then, of course, equals to 0. I think GeoGebra, you see? So that is a very good simulation now. When I pressed enter, a strange thing, you think that a strange thing has happened. Yes? Unfortunately, it does. So it opens in a slider so that it allows you to change this, but unfortunately, okay. You see, the GeoGebra is solving this immediately for every choice of m. From the -5 to 5 by default, I can change this slider. It's an extremely important tool in your hands. Okay, so let me start changing it. You see what is happening? GeoGebra is solving this equation. It's extremely important. Please listen. For m equals to -4.2. So it means that GeoGebra replace m with -4.2. It becomes a quadratic equation and solve it for you. Do you see that? How many answers you get for this value? How many? Say something. 2. Yes? You see 2. Yes? Is it a double root? No. If there are 2 different roots, that's not a double root. But let me change this number a little bit. Now I have different numbers. Is it a double root? No. But we predicted when I will have double root. If I choose m to be 2 and m to be -1, let us check the simulation. Yes? I go back here. Let me try to choose m to be -2. You see? Still I have more. Okay, I have to go forward, sorry. Yes, you are right. You see? These are all 2 roots. As soon as I reach 2 or -1 first, let us go to -1 first. Go up, 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 up. Do you see? We are close. Are you ready? 2. It becomes 1 solution. Is that clear? So what we have done? We have fine-tuned the m so that when I replace m with that particular number, suddenly the equation generated has 1 double root. And I want you to see we did something. We didn't randomly calculate it there. Is the simulation clear enough? So, and then go there. You know that when this happens again, so you see if I start moving, there are empty. You see there are no solutions. Here the discriminant is negative if you check it. Okay, but let me just move forward. What is the next one? We have to hit 2. So let us go forward. Don't give up. So we go here, here, here. So far you see no solutions. For these values of m, there are no solutions. And if I continue, no solutions still until I hit 2. You predict what happens if I hit 2. How many solutions I have? 1. And by the way, what is that solution? Exactly 1 half. So we did everything right. And then if I move forward, let us see what happens. If I move forward, you have still 2 solutions. You see? Okay. And then you can also play around, you know. So it runs the simulation itself. Okay. So I hope that you understood, actually, understand what is going on. I am fine-tuning the parameter so that I actually get what I need. So this will be definitely one of these type of questions. Of course, I will talk about these kind of questions on Monday as well. Okay, and then you prepare yourself Tuesday, Wednesday, the next quiz. Yes? Okay, any questions?
Yeah, no.
Thank you very much.